Okay, in this video I want to practice finding a basis because it's been a while since we've done that, and when we did it, it was only for Rn, not for random vector spaces. So let's try and find a basis of M23, which is the set of all matrices that are 2 by 3, 2 rows, 3 columns. So our standard strategy was to split up the generic vector in the vector space based on any coefficients that we saw. So in this case, I would write it as A times the vector, which in this case is the matrix 1 0 0 0 0 0 plus B times the matrix 0 1 0 0 0 0 plus C times the matrix 0 0 1 0 0 0 plus D times 1 in the bottom left corner plus E times 1 in the bottom middle plus F times 1 in the bottom right. Okay, so from this, I'm pretty sure that these 6 vectors don't have anything in common, that they are going to be linearly independent. So I would have to check that, but I'm pretty sure my basis is going to be those 6 matrices that are written above. I couldn't write the entire thing that's written above because that's not 6 individual vectors. A basis should be a list of so many vectors. And so we can't have any coefficients in there. We can't have plus signs in there. We have to have just a list of vectors that are the vectors that form our basis. So again, a basis should be a list of vectors. Okay, I'm not actually going to prove that this is a basis. Essentially, we have already proven that it spans M23. Everything in M23 is a linear combination of these 6. It's kind of given by this formula in the middle. We would also have to check that they're linearly independent, which would be taking a linear combination and setting it equal to 0, 0, the 0 matrix, and just showing that all the coefficients are zeros. So I'll let you run through those details if you want. But if this is the question, find a basis, my answer is a basis. I don't necessarily need to prove that it is a basis. Okay, next example, find a basis of T3, the set of all upper triangular 3 by 3 matrices. So this one's a little bit trickier just because they described it in words. They didn't describe it as something with A's, B's, and C's. So I'm going to probably try and come up with that myself. So 3 by 3 matrices, and we're talking about upper triangular. That would mean we have an ABC on the top row. We have a D and an E, but just zeros below them, and then an F in the next row. So my set of vectors in T3 look like this, and so if I do the same thing, like separate the A times 1 0 0 0 0 0 0 0 0 and so on, I'm pretty sure I'm going to get a basis that's going to consist of, again, just ones in certain spots, and then there should be 6 of them since I see 6 letters. So my B corresponds to 0 1 0 on the top. My C corresponds to 0 0 1 on the top. My D is 1 in the very middle. Had I been more intelligent, I would have picked examples for this video that were not 6-dimensional. But it seems like both of my examples are 6-dimensional. Okay, so there's our basis for T3. It's a set of 6 matrices that linear combinations of them would give you anything of this form.